Because native grasses are tall growing then, they cannot withstand persistent close defoliation. It removes the leaf surface area, which is that plant's factory, and that's true of any forage grass. It's not just natives. But when we remove those leaves, we remove all that growth, and worse still, we negatively impact that root development. Let me show you what I mean. In this photograph, we've got two big blue stem plants. One of them has been clipped to 1.5 inches height every 2 weeks to simulate close grazing. The other one has been left to grow. The important thing that we learn from this is that obviously the tops are diminished, but the roots of the clipped one are only 5% of the biomass of the unclipped one. 95% of the root mass is gone, folks. Over here, we've got switchgrass with the exact same treatment, and in terms of results, the root mass is only 4% of the unclipped one. We've taken away 96% of that root from that plant. Folks, these results are not something new. In fact, let me show you why these pictures are so grainy. They're from a study conducted in 1933. We have known for decades that we cannot beat these grasses into the dirt. We've got to leave that top growth on there, or else you wind up with 4% root mass. Now, in case you think this is just a problem with native grasses, a friend of mine, Ray Smith, up at University of Kentucky, did the very same thing, or very similar thing, with tall fescue. Put it in a greenhouse, clipped it to 1 inch, and then clipped another pot of it to 3.5 inches, which is our normal recommendation for low point of the grazing height. And what we can see is 6 days later, we had a lot more regrowth where we left a little bit of foliage. And again, same thing with orchard grass, even more pronounced. 1 inch versus 3.5 inches. Lots of regrowth, very little regrowth. So folks, whether it's native grass, orchard grass, tall fescue, we got to have leaves to grow grass. It takes grass to grow grass.